Welcome to the 2016 AP Statistics FRQ exam, question number 5. Fully explaining the answers and all the ins and outs of a really good problem dealing with confidence intervals. All right, let's dive right into it. But before we do, please don't forget to hit that like button, hit that subscribe button. It really helps me out a lot. I appreciate it. All right, so here is the question. A polling agency showed the following two statements to a random sample of 1,048 adults in the United States. Environment statement. Protection of the environment should be given priority over economic growth. Economy statement. Economic growth should be given priority over protection of the environment. The order in which the statements was shown was randomly selected for each person in the sample. After reading the statements, each person was asked to choose the statement that was most consistent with his or her opinion. The results are shown below in the table. So of the 1,048 adults in the study, in the sample, 58% chose the environment statement, 37% chose the economy statement, and 5% had no preference. Okay, so a couple key details here. This was one sample. They were only allowed to choose one option. So all of those percentages in total add up to 100%. You could not choose more than one option. You could choose environment, economy, or no preference. All right, so the first question says, assume the conditions for inference have been met, which is like awesome. Don't have to worry about checking those conditions. Construct and interpret a 95% confidence interval for the proportion of all adults in the United States who would have chosen the economy statement. So if we go back to our data real quick, 37% of people chose the economy statement, but that was what's true for our sample. What's true for the larger population of all U.S. adults? Let's find out. So first, we're working with proportions. So this is a one sample Z interval for the population proportion of people who would have chosen the economy statement. So I like to break my confidence intervals into 4 steps. So step 1 is naming it and being descriptive in terms of what it is you're looking for. We're looking for the true population proportion of all people who would have chosen that economy statement. Now, step 2 is the conditions, which we no longer have to check because it says they're all met. But I'm going to talk about them real quick anyway. Has to be a random sample to avoid bias. The sample size has to be under 10% of the entire population to assume independence. And we have to be big enough, we have to have enough successes and enough failures in order to use a normal model for our sampling distribution. Of course, those are all true. All right, so step 3 is actually building the interval. It's really, really easy. We're going to start off with what our samples show, because we have to admit that it's just an estimate. It's called a point estimate. Then we're going to go up and we're going to go down by what's called the margin of error. The margin of error is a combination of 2 things. First, your Z star, which is based on how confident we want to be. So that's going to be based on 95% confident. And then this back part is our standard error. So it's your Z star, your critical value, times your standard error. Now, the formula for standard error, when you're working with a population proportion or you're working with a sampling distribution for a population proportion, is the square root of p hat times 1 minus p hat, all divided by your sample size. All right, so now I'm just kind of putting everything in here. So first, my sample, our sample showed 37% of people that would choose the economy statement. Now our Z star is 1.96. Let me quickly show you how I got that. On the TI-84 calculator, I'm going to hit second var. So I'm going to go down to invert norm. Now, invert norm gives you the Z stars. The only thing you have to do is give it the area. Now, it wants the area in the left, the center, or the right. So notice right now it says left. If I want to select center, I can, and the area in the center would be that middle 95%, because that's what 95% confidence is talking about, the middle 95% of all possible sample proportions that would surround the true population proportion. So I could put 0.95 as the area and then select center. But most of the older calculators don't even have that option, so they're all automatically set to left. So I'm actually going to leave it set on left. And if I'm 95% in the middle, then that means 5% is left out. But due to symmetry of the normal model, that puts 2.5 at the bottom and 2.5 at the right. So I'm actually going to put in 0.025, because that's what would be the proportion to the left if there's 95% in the center. 2.5 on the left, 2.5 on the right, 95 in the center. Now, again, if you do have that option, I would select center and put 0.95. But for most of us that don't have that option, we got to put in that bottom left proportion. And that's how we get the 1.96. Now, ignore the negative. It's not that you're ignoring the negative. The negative's actually already taken account for right there with the plus or minus. So it is going to be positive or negative. All right, next up comes the standard error formula, which is also fairly easy. I just talked to you about it. So it's the square root of your sample proportion, p hat, 0.37, times the opposite of that, 1 minus 0.37 is 0.63, divided by the sample size, 1,048. Now, I would much rather be using the standard deviation, but the formula for the standard deviation of a sampling distribution is p times 1 minus p, all divided by n. But I don't know the true proportion. That's exactly why I'm looking for it. So when I have to replace the p with the p hat, that's when we use standard error. All right, so using my calculator, you could go ahead and multiply 1.96 times the square root of 0.37 times 0.63, all divided by 1,048. We get a margin of error of 0.0292. So that's basically admitting like, hey, listen, I got 0.37%, but it could be a little bit higher, could be a little bit lower. So add the 0.0292, subtract the 0.0292, and we get our confidence interval, 0.3408 to 0.3992. Now, step 4 is the actual interpretation, because it did say to construct and interpret the interval. So here's where I'm going to say, hey, listen, I'm 95% confident that the population proportion of all United States adults who would have chosen that economy statement is somewhere between 34.1% and 40%. I rounded them each to, I guess I could have said 39.9% if I wanted to be a little bit, but rounding to 2 decimals, 34%, 40% is where we're looking around for this true population proportion that would select the economy statement. All right, now for part B. One of the conditions for inference that was met is that the number who chose the economy statement and the number who did not choose the economy statement are both greater than 10. Now, real quick, this is one of those conditions that we did not have to check, but we already knew that 37% of 1,048 people chose it, and 63% of the 1,048 people did not choose it. Both of those numbers are greater than or equal to 10. But why is that condition necessary? Well, it all comes down to the sample sizes. It needs to be big enough. If the sample size is not, quote unquote, big enough, then the normal model will not be a good approximation for that sampling distribution. Again, confidence intervals are built on the idea that if we're looking at all possible p-hats, not just ours was 0.37, but this sample, or this sampling distribution, is filled with all possible p-hats. Very few are going to be extremely high, very few are going to be extremely low. Most of them should be in the center surrounding the true population proportion. But the idea is I need that sampling distribution to be normal. And if my sample size is not big enough, it doesn't contain enough successes and failures, it's just not going to be big enough to follow that. Really, it all comes down to the binomial distribution. When you're working with proportions, you have either success or fail. They either chose the economy statement or they did not. And if you recall, being able to transition from the binomial distribution to a normal distribution, the requirement is that we have 10 or more successes and failures, or that transition from the binomial model to the normal model is honestly just not going to work out and be good enough. So that's why we need those 10 successes and 10 failures. All right, and finally, question C. A suggestion was made to use a 2-sample Z interval for a difference between the proportions to investigate whether the difference in proportions between adults in the United States who would have chosen the environment statement and adults in the United States who have chosen the economy statement is statistically significant. So somebody suggested, hey, why don't we look at the difference between those that chose economy and those that chose environmental statement, and let's do a 2-sample Z interval for the difference. Is a 2-sample Z interval for the difference between these two proportions an appropriate procedure to investigate the difference? No, it's not a good idea. Here's why. In this scenario, there are not 2 different samples. It was one sample of 1,048 people, and we allowed them to choose one option: environment statement, economy statement, or no preference. This means that the proportion of people who chose one selection affected the other, therefore the choices are not independent of each other. Again, if 63% of people chose one, then 37% of people chose another, or whatever proportions, right? You can't choose more than one. So this cannot be a 2-sample Z interval. A 2-sample Z interval for the difference is looking at the difference between 2 distinctly populations. So maybe we want to look at what proportion of men would choose this statement versus what proportion of females would choose the environmental statement, right? In that case, we could do a 2-sample test because we had 2 distinct samples. We let the men choose, we let the women choose, and then we looked at the difference. That would be a good example of where I could do a 2-sample z-interval because those 2 groups would be independent. The group of men did not have a change or not have an impact on what the women were going to do. But if we only have 1 sample, if I pick the environment statement, then the chance of me selecting the economy statement instantly drops to 0. So what I did affects what I did on the other statement. So what I chose for the one is going to impact what I chose for the next. It's choosing this versus not choosing that. So hopefully I'm saying that very well to you, but it's the idea that it's not what a 2-sample z-interval is for. A 2-sample z-interval is to explore the difference between 2 different population proportions. So I have to have 2 different groups selected from those 2 population proportions, from those 2 populations. That way I can analyze, hey, what did this group do versus what did this group do? And I can look at the difference. Here, I only have 1 group. I don't have 2 independent samples from 2 different populations. All right, hopefully all that makes sense. And again, this is another one of those really good problems where the part A is where there's a little bit of work, but this is not too difficult of work to do to find that confidence interval. And the other parts are more focused on, do you understand the aspects of this problem? So hopefully it's one of those good ones that you can get a really good grade on. All right, see you later.